All right, everybody. Thanks for joining us. This is Scott Bradley and Nick Narzinski with D3 Technologies. And what we're going to go over today for about half hour is the conversation around Fusion 360 CAM for our SolidWorks clients, the customers who are utilizing SolidWorks as their main CAD package and platform. We're going to discuss how Fusion 360 is a great complementary tool for other aspects of their design, but primarily for the machining phase of their process. And we're going to discuss the CAM functionality within Fusion 360. And we wanted to start just to go over Fusion 360 a little in more detail and discuss the platform and make sure everybody understands what Fusion 360 is. And then we're going to go over to Nick and discuss more about the CAM and machining aspects and how that process looks. So what this screen is here, Nick has gone to the Fusion 360, and Fusion 360 is just a cloud-based 3D CAD and CAM package that brings in a lot of tools to complement a 3D CAD package. So you're going to get a lot of options and very powerful tools such as simulation tools, CAM package like we already discussed, parametric modeling, so there is a 3D modeling aspect to Fusion, and then of course some advanced manufacturing capabilities within the CAM world, 2.5, 3-axis, 5-axis, and turning within the CAM package. Fusion 360 also brings together, with the help of Fusion Team Hub, some abilities to collaborate and manage your data and share among a team virtually through the cloud platform, so that teams can collaborate, mark up, share ideas, and work on the same projects at the same time. And so, you know, at that, go check out Fusion 360 on Autodesk's website to learn more about the different options, or give us a call here at D3 Technologies, and we can discuss Fusion and how Fusion Team is going to help and fit within your process. Nick, if you want to switch back. Yeah, as I mentioned, we've got myself, I'm Scott Bradley, the Territory Sales Solutions Executive here with D3, working primarily with our machining customers. And then Nick Narzinski is our specialist for CAM, HSM, as well as Fusion 360, whether it's for SolidWorks or Inventor users. And Nick, do you want to take over and go into your presentation today?
Thanks, Scott. So, as Scott mentioned, my name is Nick Narzinski, and today we're going to take a look at how to bring your SolidWorks models into Fusion 360 and then program them for CAM and output your G-code. So we're not trying to get you to convert to Fusion 360 per se, but use Fusion 360 in conjunction with your SolidWorks or Inventor or whatever other CAD platform you may be using. So our learning objectives for today, we're going to take a look at the user interface, specifically how you can manipulate Fusion 360 to kind of work with the same type of controls that you use inside of SolidWorks. Then we'll look at how to upload those files. We'll quickly run through programming a part file. Then we will discuss the collaborating, as Scott said, in the Fusion Team Hub. And then we'll take a look at how you can actually edit your models directly inside of Fusion and then update your toolpaths to those changes if a customer called up and wanted to make some quick modifications. So first thing, as I said, is the user interface. So here's just kind of a screenshot of how different things line up between SolidWorks and Fusion 360. We'll take a look at how to manipulate your pan, zoom, and orbit shortcut to be the same as SolidWorks, where your browser and timeline are and how those work, and then also your data panel. So let's just jump into the software, and I'm going to kind of go back and forth between the PowerPoint and the software as we run through this presentation. So here's a part that we have drawn up inside of SolidWorks, and so with that, you can see the browser on the left side. You guys are used to this interface, and you got your different panels up on the top. So with inside of Fusion, along top, you have your different modeling environments, your CAM environment, simulation, mesh. We're also very good at T-splines, so you can use the meshes for that. On the left side, you will see the browser, similar to what you have inside of SolidWorks, except for the timeline. In Fusion, it's a little bit different. You've got your bodies and your origin up on the left side in the browser. Along the bottom, as you parametrically modify your model, so let's just take, for example, if I say capture design history, you can then see down the bottom we have a timeline. So all of your features and sketches that you add are going to be shown along the bottom, and you can play those out and see those as they were being built. And then the left side, like I said, is going to show your bodies. If this was an assembly, you'd see the different part files within there as well. And then the other thing that you will get used to using in Fusion 360 is the data panel. So here on the left side, by clicking this button here, you'll be able to see your different projects. Within the projects, you'll have your folders, and then within the folders, you'll have your different part files. So we're going to run through, this is one that's already been done. I'm going to run through how to import, and then we'll jump into programming that. So, one more thing I forgot to do is your interface and how to edit your pan, zoom, and orbit shortcut. So let's take a look at that real quick. By default, if you go up here to your name, when you log into Fusion 360 and go to Preferences, you will see by default it's going to be at Fusion. If you change that pan, zoom, orbit shortcut to SolidWorks, it will change to where you hold down your mouse wheel and that rotates the model just like SolidWorks. Your zoom in, zoom out. Just by rotating the wheel, if you hold down Control and hold your mouse wheel button down like a button, that does your pan. So this, by changing that, it will change your controls with the mouse and the keyboard to be the same as SolidWorks. So in that aspect, it'll be a very seamless transition to manipulating the view of your model. One thing that's a little bit different is this view cube up in the top. This you can use to rotate your model as well. So you got your home view. You can click on the different faces or the corners of those models to look at a certain view. So that's always up on top versus SolidWorks. You've got your view cube here that you can bring up and manipulate your model like that. So pretty similar there. All right. The next thing is uploading files. So today, for our example, we're going to take a SolidWorks file that we seen earlier. This part file, we're going to upload it to Fusion 360. So to do that, we simply, I'm going to go back a folder here. Go back to my project. And let's just close this one that's already done. Okay, so I'm going to hit upload here. Now you could drag and drop files into this space, or you can hit select files here and just browse to the file. In this case, it's going to be beam support. I'm going to hit open and then click upload. And you'll see it run through uploading that file into my project. And you can close this window as it's going also. Once that's done, we'll be able to right click on this, there it goes, and say open. This will open that part file directly into Fusion 360. So it's not importing all of the CAM features or all of the CAD features and how this part was built, but it imports it as a solid model. Now with that, we can jump straight into, let's pull up our PowerPoint again, program that part. So we're going to go through quickly programming the SolidWorks model directly inside of Fusion and then how to generate that G-code. So first thing we're going to do is change from our modeling environment. We'll come back to this here in a little bit and how to manipulate the model. But in this case, we're going to switch to the CAM environment. And the first thing you're always going to do to program a part is a job setup. So this is where we're basically defining our stock as well as the work offset and where you want to place that. So in this case, I want my Z to be pointing up towards the spindle, so I'm going to click the stem of the Z, click the face I want it perpendicular to, and that's how easily you can orient your coordinate system. Then if I click that dot at the 0, 0 point, it pulls up different points on my stock here, and then I can just select one of those, maybe if I'm going to use and touch off that top back left corner as my G54. Then you can move over to the stock tab, and you'll notice almost everything in here, you're just working left to right in these dialog boxes. So I'm going to click to the stock tab. Let's make this a fixed size box. Right now, if I look at it, you can see it's flush on the ends. I want to have some material there after this stock is sawed off. So I'm going to go with 4.625. The rest of it looks good. I do want to have a little bit more material here to grip on the bottom. So I'm going to say offset from top. And then I'm just going to put in a 20 thou offset. So now you can see if I zoom way in here, we got 20 thousandths of stock on the top of the model, and that gives us a little bit more material to grip on to the bottom of the model. Last thing is the post-process tab here. I'm just going to put a comment in, and then offset 1 for most of the post-processors here represents G54, 2 would be G55, and so on. But that is independent on the posts for your machine. So I'll say OK. And now you can see within our CAM browser here, we have our first setup. And there's a little dot that's selected after it. That means that this is the active setup if you were to have multiple setups within inside this file. So first thing, let's just add a facing operation to machine off that 20 thousandths. So once we started that operation, you have these 5 tabs. These are the same 5 tabs for all the milling operations. So you're just going to work left to right again. First thing we're always going to do is select the tool. So I'm going to come in here to my tool library. It has some suggested tools here based off of the defaults that come with the software. I'm just going to click this, and I only want to look at face mills. So I'm going to click none for selection here, select my face mill, and say OK. I can see there is a 2-inch face mill that's already in the software. I'm just going to say OK here. And I'll look at the geometry tab. This is where you would make a model selection. In this case, they did a really good job with the defaults in the software. So facing is always looking within the stock boundary down to the top of the model. And then I'm just going to say OK. So here you can see it leads in outside the stock, and it does its passes to remove that 20 thousandths of material. It's also very simple to run through making up modifications and simulating. So you can, as soon as you create a toolpath, you can jump right into simulation and play that out. So here I've got my toolpath turned on, my stock turned on. And there you can see that stock being removed. And if you need to go back and make changes, you can go back and make changes to that. I've got it in loop mode, so it's just playing over again. Let me turn that off real quick. There we go. Okay, so next thing I'm going to do is rough out all of that stock. So to do that, I'm going to use adaptive clearing. This is also a very nice feature within inside of the HSM for Fusion software. It's also known as high efficiency roughing or high speed machining. But basically it's a toolpath that takes into account the load on the cutter based off of the tool engagement angle at all times, and based off of angular changes in the toolpath, it will either add or remove material on its passes to keep that load consistent at all times. So I'm going to jump back into tool library again. This time I want a bull nose end mill. So I'm going to select that, say OK. Let's find a 1/2 inch. We're going to go with aluminum for our material here. So this is within the aluminum library. It has recommended speeds and feeds for aluminum. I'm going to say OK. Again, the geometry is looking within, so these 3D toolpaths are always looking at the stock and the model at all times. So in this case, by having none for our machine boundary, it's looking within inside the stock down to the model as it is. So it sees that model and it knows where it is, where it can machine. In this case, rest machining, I'm going to say from previous operations. That way it recognizes that facing operation that was that preceded this. And then let's take a quick look at the passes tab. Optimal load here, that 200 thousandths. That is, let's say in a straight run, that would be your step over. Like I said though, it adjusts that based off of tool engagement angle changes. And Stock to leave down here, this is by default a roughing operation, so we're leaving 20 thousandths of material on the sidewalls and the bottom of the tool. So what it's really doing here is a bunch of tiny point-to-point movements. So typically this is only used as roughing. You come back through, which we're going to do here in a minute, and put some finishing passes on. So I'm going to say OK here. It's running through calculating that tool path. So there's our roughing operation. I am now going to follow that up with a finishing tool path on the flats here. So to do that, I'm going to go back to 3D and select a horizontal tool path. This is kind of a neat tool path that goes in and puts finishing passes on all the flat surfaces it finds in your model. So I'll go back to the library. This time I'm going to get a flat end mill. I'm going to find that 1/2 inch again. The geometry tab, again, machine boundary, I'm going to say none. It's just going to look at the entire model. This time I do want to manipulate the heights a little bit. You can see here we have a retract height, clearance height, top height, and bottom height. So this is between the top and the bottom height. That's basically what we're telling it as a boundary in the z-axis that it can machine or find those flat surfaces. In this case, I don't want it to look at that top surface because we already faced it off. So I'm just going to drag my top height just down past the top of the model. That way it takes that out of its calculation, basically. And it's only going to see the flats between our top height and our bottom height. And then passes tab, this is where you would set your step over, if you want to put a manual step over in there. You can also go to the linking tab, and this is where we see how the tool path enters and exits. In this case, I don't want to helix down. I'm just going to tell it to plunge. And we'll say OK. So there's our finish on all the flats. The last thing that would be to come in and do a finish on our sidewalls. And actually, I meant to go back to that horizontal, and I wanted to leave that same offset on the side of the tool. So I'm going to say radial stock, 20 thousandths there, but axial 0. So that way I can come through with a tool path directly on the sidewalls and do just I'm going to do a step down to prevent any type of tool deflection, or at least minimize the tool deflection. So I'm going to go 3D again, 3D contour. I want that same 1/2 inch tool. For geometry, I'm going to look at the silhouette, but I'm going to say the tool has the ability to go outside the boundary. That way it has the ability to come out and machine these outside faces of the part. And then for the heights, I might go just a little bit past the bottom. So I could drag here, or I could type in a negative, we'll say 10 thousandths. So that way the part goes, our tool comes just a little bit past the bottom of the part. And then for passes, I'm going to say a maximum step down here of 25 thou. And then for linking, I do want to plunge this again. So let's say OK there. All right, it didn't go outside like I wanted to. Let me check something real quick. Ooh, I said 2 inside. I meant 2 outside boundary. I think I said that, but selected the wrong thing. That looks a little better. So we got just 25,000 step down to finish those sidewalls. So once that's done, we can run through a simulation of everything together. It's always good to simulate before you post or run the tool path on your machine. So I'm going to go highlight the setup. So that way we simulate everything. Go up here to my actions and click simulate. And here I've got the holder, toolpath stock turned on. Look at that. We can see before we even run this toolpath that we do have a few collisions. That's what these red lines represent. You can also go to the info tab and see any collisions there are also. So I'm going to turn on stop on collision here, and let's just play that out and see what happens. So as it's running through, it's adaptive. It looks good so far. We get to our first step down, and there it stops. We can see that the holder collides with our part. So our tool didn't have a long enough stick out length. So we could go through measure the part, change the stick out value for that tool in the library. Another neat feature we have in here within most of the tool paths is you can go into the tool tab. Down at the bottom we have shaft and holder detection. So if I turn that on, I can say detect my tool length for this tool to create a holder clearance of, and put a value in there. In this case, we're going to say 200 thousandths and say OK. It's going to run through and recalculate that tool path. And then we should get a little warning symbol over here, just like that. If I right click and say show log, here I can see the tool length has been updated from 1.1 to 1.92. So basically it automatically went into our library, updated the tool stick out length, and then recalculated that tool path based off of that. And we're going to get the same error on the contour. So I'm going to go ahead and change that for the horizontal, or was it, no, it was the contour. So we're going to say detect tool length again, 200 thousandths, say OK. Now that tool is used in the horizontal also, so that's why you see invalid tool path as soon as I calculated that. So it did update the stick out length for that tool, the 1/2 inch flat. I just need to go back and regenerate the horizontal also. So kind of neat there. Even though we updated it in the tool path that came after it, it automatically told us there with that symbol that, hey, this needed to be regenerated because our tool stick out length has changed. So now I can run through and resimulate that again. And this time we don't have any collisions. It looks good. I'll just quickly run through the simulation. And how are we doing on time? Getting pretty close. So simulation looks good. You'll notice we couldn't machine all the way to that corner just based off of the radius of the tool. So we could go in there and modify the tool or modify the part file and put a little cope back in that corner, or you know, it may be acceptable depending on what the our customer needed as far as that goes. So next thing would be to post-process. Came up on the other screen. So here I have just a generic cost post-processor. We have post, and this is where it's going to generate our G codes for that machine. So we do have a large library of post-processors. If you guys need help modifying those posts, we do also modify posts. Here you can see there's that comment I put in our job setup. There's our number, and then here's your different operations. So then you'd save that and load it on our machine. Another neat feature we have in here is for the operators, you can do a setup sheet. This gives us a good image, location of the file, what stock size to use, and then what tools to load into what holder, as well as a breakdown of the parameters for those operations. So really good information there for your operator. All right, so let's say we got all that done. We wanted to share this with the customer and make sure everything looked good. We could go back to our, well, here, let me jump back to our presentation. There we go. So now collaborating. So how to add comments and share with the Fusion Team Hub or also A360. So let's jump over here to our data panel. You can right click on this and say start live review if you want to do a live review with the customer. You can also let's save this real quick. We'll say CAM. So each time you do a save, it creates a different version. So if you ever have to revert back to a different version, you can go through those. Let's finish saving. Here you can do a share public link. This gives you a link that you can actually send to your customer so that they can open up. You can allow them to download it too. So real good with sharing, or you can even password protect this. What I wanted to do. do that start live review. Oh, how to, oh, here we go. Sorry, I had to click the version, open details on the web. Took me a second to find it there. This is what I was trying to find. So this is going to open up in your hub. Inside of there, after you send this link to your customer, this is how he would see it. So he would be able to open that up, look at the part file, rotate it. You can also go through and mark comments or mark it up. So in this case, I'm going to say comment on point. Let's say on this edge right here, we wanted to tell them to add a 16th inch chamfer. You add that comment. It's going to run through and save that. You can see the number there. You can go ahead and add more comments or click on them to see what that says. So now we can jump back into Fusion. I can go down here to where it says comments, click the plus sign. Let's refresh real quick. And then down here, you can see, let's make this a little bit taller. Down here, you can see add 065 chamfer. I can click to view, and it brings up that comment as well. It tells me where that point is. So now I can go through, and this is where direct modeling comes into play. So here, capture design history, you can or you can't, and then quickly make changes on the fly. There's Fusion. So back to the modeling environment. If we right-click on our part file up here, down at the very bottom we have the option to capture design history. Or you can modify the model and not capture. So capturing is like parametric modeling, where you keep track of all the changes that you make. Or we can do direct modeling and just make the changes and not worry about capturing that information. So that is up to you on whether you want to have that to capture that information or not. But let's turn it on for this part. And then I'm going to come up here and do a press pull. Neat feature, it works directly on the model, so you can select any surface and go in and directly modify that. In this case, let's change that to 1/4 inch. So if you type IN, even though that this is looking at it as a metric, we can type in inches there and it automatically makes that conversion. And if you ever wanted to change units, you can simply click that button there and change it and change your units also. We also wanted to add that 16th inch chamfer, so I'm going to click chamfer up here, select that edge, put in our chamfer, and say OK. So with that, then you could switch back to the CAM environment. You'll notice you have a bunch of red marks here specifying that something's not correct. In this case, we just new model. So I'm going to right click here and say generate toolpath. You'll run through, recalculates, and you can see the face, the adaptive clearing is now down to that new surface. Our horizontal is down to our moved surface there as well. And then you've got your contour operation. We would need to go ahead and add probably a 2D contour to this bottom edge without. So if I hold down the Alt key, a little trick or tip here, if you hold down the Alt key, it only selects a single edge. Without the Alt key, it tries to do a closed loop. So I'm going to hold the Alt key, select that edge, and pick a chamfer tool. And we'll pass this tab. I'm just going to do a tip offset here. Slide the tip of that tool down just slightly. So that's how easy it is to just add a toolpath to that. And then you can repost that code and you're ready to rock and roll. So hopefully it gives you guys a good understanding of how the workflow is from your existing SolidWorks or CAD environment into uploading files into Fusion 360 and modifying them, and then how to collaborate with your customer as well. So if you guys have any questions, please reach out to Scott or myself. This has been recorded, so we will send it out to anybody who was not able to join us live, and I look forward to speaking with you guys.